Hey everybody, thanks for tuning in and I hope you had a great day so far. We learned a lot about machine learning today and I hope some of the sessions were insightful. We looked at things like Alexa for Business, Amazon SageMaker, machine learning models that you can use, APIs that you can call to understand video recognition or image material. We built chatbots, so lots and lots of learning today. And with that in mind, we keep talking about how easy it is to actually build things on the AWS platform and specifically build machine learning models. So with me here, I have Glenn Gore, our chief architect, and myself, Oliver Klein, heading up the emerging technologies. And we said, how about we give ourselves a challenge here? Right, Glenn?
Yeah, sometimes we come up with ideas that at the time sound like a great idea, Ollie, but in the midst of it and right now as we're coming to you live from Singapore, sometimes I do wonder, was it the smartest thing to kind of set this challenge? So knock on wood, hopefully the demo gods are going to be kind to us. We've got some good demos that we think we've built over the last 2 days. And we're going to showcase you and kind of try and show you some of the differences between the different machine learning services that are available to you and maybe some of the use cases where you may use one over the other.
And with that in mind also, we actually have a laptop here that comes in with the questions that you actually ask. So if you have questions around what we're doing, what we're building, or the services, we are able to see them here and are able to answer also some of them here at the end.
Yeah, at the end we'll, if hopefully we've got enough time and the demos go well, we'll see what popular questions are popping up as well.
Now with that in mind, there's some other current events that are going on. Glenn, are you watching the Winter Olympics?
Yeah, I am actually. I'm a big mountain fan, love skiing. It's absolutely incredible just watching what the human body is capable of at its pinnacle. I tell you what, how they land some of those jumps, I have no idea.
It's absolutely amazing. I got to say, this man is guilty to really get me into skiing. I went skiing with this fella once, and he went down the hill. I was like, are you doing the Olympics? Are you doing the Olympics?
Everyone's an Olympic skier in their mind, right?
So with that in mind, I thought like wouldn't it be interesting to understand what it is about, the Olympics? A lot of people are talking about it. When people are talking about it, I always ask myself, what's the sentiment about it? What are people talking about when they talk about Olympics? Is it positive? Is it negative? And what we can do is obviously like go on social media and kind of look at the different posts that we have and see what people are posting or tweeting about. But I always think that's kind of biased because we have our own friends and followers, so we get a very myopic view at looking at what people are actually talking about.
There's been a lot of talk about the echo chamber of social media. So let's be data-driven about this. Let's actually look at a big volume of kind of social media posts about Olympics and see what the data tells us.
Exactly, and so with that in mind, Glenn and myself, we set ourselves in its 2-day hackathon a few ideas. The first one was, could we use social media in the specific example, for example, Twitter, and try to understand the sentiments that are going through with all the tweets using something like Amazon Comprehend, so that we don't need to build our own natural language processing or language understanding kind of models. And I know, Glenn, you built some of it out here in a live demo, but before you're going to show that, I figured, wouldn't it be fun if I tried to understand how you would build that architecture?
Yeah, well, you wouldn't be an architect if you don't use the whiteboard. So with that, why don't you have a draw of how you would build it, Ollie?
So what we're going to do here is we use a variety of services that allows us to understand the sentiment of the tweets. Now, the bottom line is we're actually going to get this off Twitter, of course. Now, the beauty of this is that Twitter has APIs that we can tap into, and with that in mind, we could tap onto the tweet API and actually channel that into a service for further processing. So one great service would be Kinesis, which is our real-time data processing service, but specifically an extension of it, which would be Kinesis Firehouse, which allows us to forward those messages fully managed into a variety of places. Now, the first thing that I always say, if we collect data, it's a good place to store it somewhere for further later analysis or historical analysis. Build out a data lake with the information that we're collecting. Now, a good place to put that would be Amazon S3. And from there, we can always take it for more historical analysis. However, here in this live demo, our idea was, let's try to understand the sentiments as they happen the very moment they happen. So one other thing that we could do is we can actually send it to an AWS Lambda function. Now, if we send it to an AWS Lambda function, why do we do that? Well, in an AWS Lambda function, we can make any kind of API calls. Now, as you know, Amazon Web Services are all web services, meaning everything is an API. as such, what we could do is we could send now that tweet to Amazon Comprehend. Make that API call, and that allows us to do a few things. Understand the language, extract the key entities, understand what's going on, but specifically also get the sentiment out of that tweet. Is it positive? Is it negative? Is it mixed feelings? I think we saw some funny tweets coming through over the last hours around mixed feelings, but it allows us to get those sentiments. And the next thing what we can now do is we actually put that obviously in a data store somewhere, and specifically a database. Now, there are lots of options, caching options, NoSQL options like DynamoDB. I figured, I'm very comfortable with SQL queries sometimes, so my choice here would maybe be a relational database, but one that scales really well. So if you use the relational database service, we can actually tap onto the Aurora engine, which is really built for a lot of scale in this kind of scenarios. Why do we do that? Well, because from here, we can actually use a business intelligence tool or service such as, for example, QuickSight, plug it in, and actually start visualizing what's going on, build graphs around it, or more specifically, maybe even go ahead and build a website which would query the most positive or negative tweets that we're getting. So, Glenn, this would be my take on an architecture and how I would build something like that without actually needing to understand the natural language understanding or processing here by using Amazon Comprehend. So what have you built, Glenn?
So suspiciously very similar. I kind of feel this is almost like one of our interview questions we ask architects to go through. So that is pretty much exactly what it is. Now, you're kind of right about the Aurora database. It is using Aurora for this live demo that I'm going to show you. DynamoDB was another contender for it because it's actually really good for this type of use case as well. One of the challenges was I wanted to use QuickSight just because of that 2-day limit. And QuickSight only plugs into kind of a SQL standard databases or doesn't support Dynamo natively at the moment. So with that, if we kind of have a look at what we see over here, looking at the data, Ollie, the original question we had was, is it more positive or more negative? And this is the graph that kind of proves this in a data-driven model. So what we're seeing here is kind of tweets by the hour. The top line here is actually the number of positive tweets, and the light blue line is negative tweets. So you can see positive is definitely outweighing negative. But what's interesting is you can see that the volume of tweets is actually changing depending on what's happening with the sports activities. Ice skating. Apparently a lot of people really like ice skating, which is interesting because we're going to come and dive into that in a little bit. If we scroll down, the other interesting offset is this kind of language breakdown, but it's easier to see on this graph. Korea. Korea, you are absolutely blitzing it in terms of number of tweets by language type. You're beating all the other English-speaking countries, which is actually a bit of a surprise.
Yeah,
I would have thought
absolutely.
English would have been more, given that Twitter usage in Korea is not all that high, and then Japan. But one of the things I like about QuickSight is we can kind of go in and use X-ray, which is a feature of QuickSight that allows us to kind of see what are some intelligent insights that it's working out itself. And you can see here that actually the top 3 languages represent 90% of all the tweets. And we've actually processed 586,000 tweets. So I think that's pretty good data driven. Now we talked about, well, what is the actual tweets looking like? And you can see here some of the positive tweets as they go down, some of the mixed tweets. As we drilled into this, we kind of realized in the negative tweet space, yeah, there's a lot of things that aren't quite safe to present in this demo. Mixed tweets, there's some interesting things here about people, loving the ice skating but questioning the music. But a better way to look at this is kind of that website you were talking about. And so again on the screen, what you can see here is this is kind of just a live update of the Lambda function public into the database. We're just pulling off any of the positive tweets that are more than 90% confidence that it's positive. And you can see here people are posting things, I'm glad they added snowboarding. On the negative tweets, there's a couple of trends there. One, people don't like it when people are crashing, whether it be skiing, boarding, or the ice skating. A lot of people have some pretty strong opinions about the music choices for the ice skating dance routines. Also, a lot of people getting upset about Canada winning a lot of medals. But one of the things I looked at, Ollie, when you look at that architecture diagram on the whiteboard again, there's a lot of components here, and one of the things we like is, kind of this, a lot of customers like this real-time analysis. What can they do? Because the quicker you can detect and react, often that can give you an advantage. So let's do kind of our first live demo. So
All right.
what I'm going to do is, and by the way, all of you at home or in front of a screen doing this, you can actually do this. What we're going to do is if we take a tweet and we put hashtag Olympics, and if I can spell it properly. And what we're going to do is if you just say something really positive. So it's an awesome event with great athletes from around the world. I can't type live, obviously. Incredible.
Amazing.
Fantastic.
Fantastic. You're a positive person.
So this is positive, right? So if we tweet this, what we want to see on the screen when I press on tweet is we should see it come up over here as you just saw it update there. So we're going to tweet and bang, there it is. So you can see the latency on this is actually incredible. Being able to plug it through the Twitter API itself, through Comprehend, which is actually doing some pretty sophisticated machine learning against text. Now, Ollie and I were only just showing you kind of sentiment analysis, but there's a lot of things Comprehend can also do, and it is doing, that we're just ignoring at the moment. For example, it's looking at the key phrases that are used in that Twitter. It's identifying names, dates, key attributes as well. You can also feed it thousands and thousands of documents or look for common topics, for example. So there's a lot you can do with Comprehend. We're just scratching the surface. So it was a fun demo.
You know, Glenn, what I find actually also quite interesting is that you're still in Europe time zone here with 1:25
I am.
a.m.
I'm doing pretty good.
You?
Jet lag is, if I yawn, it's not the demos. But, Ollie, again, this is text-based. And text is kind of fairly easy to understand what it is. We can read it. Text is text. But a lot of customers are asking about, that's great, but actually I have massive amounts of image data.
Yeah.
How do I start processing these images and start getting more information around what is the content of these images? Because in the past, that's been incredibly computationally difficult to do, either at a small scale, but particularly when you start talking about, for example, newspapers that could have 100 years of image data going back and they're wanting to process that. Suddenly that problem becomes massive.
Absolutely. And I think what we've observed over the last years is really an explosion in the use of deep learning networks, and specifically convolutional neural networks, which have really advanced the idea of what information can we extract from images. And as we went through the tweets yesterday, I saw there are lots and lots of picture material that comes through. So how do we move from text, which is already great, we get a good understanding of what people are talking about us, how can we get a better understanding of image material, what people are posting in terms of image material in this scenario, right? Maybe you're a big Instagram user in that scenario. Are you, Glenn? You got to get on Instagram.
I don't have an Instagram account.
No Instagram account for Glenn Gore. All right then. So I can't analyze you with image material, but I think a lot of people are actually using images. So let's try to understand how we can make use of that. Now, if you tuned in earlier into the session about Amazon Recognition, you are aware of that service. Now, what is Amazon Recognition doing? It allows us to actually understand what's going on in a picture, in an image, or even in a video. And it allows us to identify objects, it allows us to identify faces, celebrities, it allows us to do image moderation, etc. So I figured, how could we actually make use of that? And so in our little challenge here of the 2-day hackathon.
Nothing like live video, huh?
Nothing like live video, right? In the 2-day challenge, I figured, let's actually try to do something that's also live.
So what did you build, Ollie?
So what I went ahead, I said, let's build a little website and try to use Amazon Recognition from my webcam of my laptop. So let's switch over here to my laptop. And if we look at this small little website here, if you look at the address bar and the top corner, it is actually running on my local host here. So this is a small little HTML page here that we created. Taps onto my webcam here using JavaScript. And now with the idea in mind that everything is an API call, what we can do is I can take frames from my webcam here and actually send it to Amazon Recognition using JavaScript, get the labels back, and able to display them in the browser. So if I start recognizing objects here, what will happen is we actually start talking to Amazon Recognition, and as you see now, we slowly start getting certain information back here on the corner. So human, people, person, there's an arm, there we go.
How about can you deal with props, for example, like a car?
Let's have a little car that comes in here. And as you see, we always like to try things out with interesting kind of objects. computer, electronics,
Well,
clothing,
car,
automobile. Let's try a funnier one. Let's look at
Lightning
this little.
McQueen.
Let's look at this: a car, Formula One, race car, sports car. So this is a lot of fun. Now I can start understanding video material here, actually on the fly, actually from my browser, straight into Amazon Recognition without ever having built any convolutional neural networks. Right? Great to kind of understand video like that, isn't it?
Now, Ollie,
Right?
there's a part of me that suspects that you may not be telling the full truth here. Did you cheat at all? Is that really live video?
I mean, it was a 2-day hackathon. Glenn.
Come on, Ollie. What did you do?
All right, I did cheat a little. So what you see here is actually a webcam that I take, but instead of actually sending it to Recognition Video, I went ahead and said, what if I take every second a little frame, right? And just send that to Amazon Recognition Image and get the image material out of it, so I don't need to stream all of that video into Amazon Recognition Video.
So you're just taking the single image screen grab basically and uploading that as fast as you can.
Exactly. Every second little
It's
picture.
not exactly
right?
video, is it?
Well, it does the trick. I understand what's going on in the picture.
It
no?
does. Well, what about if we actually did do with some videos? So if we look at, for example, Kinesis Video, which is a way that you can start consuming video streams live or batches of videos from millions of devices around there, you can do some interesting things with it. You can store it in S3, you can plug into other services, you can plug it into your own machine learning frameworks, or you can even plug it directly into Recognition Video. And so to give you a little bit of an idea of what we can do with video, this was on the screen here. You can see this is a video that I took earlier, just before we went live actually. We just play it. This gives you a bit of an idea of if it's going to play. Expand width is a bit of an issue. This just shows you the room as we were setting it up. There's Ollie. What I love is it's actually detected Ollie as a celebrity, which we'll see.
I know how I train my models.
So this is what the room looks like. And we click on celebrity, for example. One of the things you can see is the little orange bar here says this is the time in the video where a celebrity was found. I didn't know you were famous, Ollie. Interesting, it's still trying to work out exactly who you are, so whether it thinks you're not. But this is kind of batch processing, and in this it's looking at faces, celebrity matching. You can see that it's looking at, for example, where did we see a whiteboard in the image, so you can see again it's putting where that is. It's getting thing in the screen is a whiteboard. But again, this still isn't live. So one of the things we wanted to do was look at what can we do with a live demo. And so, well, that's not going to work while I click on that. So while on the screen there, you may see live video coming through. Now, one of the challenges with this, Ollie, is that we're kind of running this locally, doing a lot of processing with it, then sending it all the way over to the US where the service is running for Kinesis Video, processing and then sending it back. So it is a little bit laggy. It's kind of like my little doppelganger there.
Yeah.
But what I'm going to do is I just want to draw on the whiteboard again what we've actually built here, because it is quite new and a combination of some many pieces that are still, kind of in, very early stage of adoption here.
So while Glenn is getting over to the whiteboard, I want to see who's now the better architect here, because we always like to draw on the different whiteboards. And my mistake was I didn't clean that whiteboard, so now Glenn is wiping it for me. All right, Glenn, show us your architecture.
All right, well, warning, I'm never, ever going to win any drawing awards. So what we've got is we've got a webcam. It's on the laptop. Now, this webcam is just a kind of USB-enabled device that's connected directly to the laptop. Now, when we did this, one of the first things I had to solve was, well, how are we going to capture? Now, you're using HTML5 to capture your webcam, which is nice and works. Unfortunately for this, we needed to work natively with the hardware itself. So the first thing I was thinking, well, let's use Java, because that's actually, I feel like I'm in a therapy session admitting this, but Java is kind of the language I know the best recently. And so you're having to play with JNI to interact with hardware. It didn't exactly go to plan, so I ended up having to go back to using C. So what we're doing is we're running a script on the laptop that's capturing this video. It's then chunking it up into small chunks. And it's actually uploading this into Kinesis Video. Now, what Kinesis Video allows you to do is just like Kinesis data streams, it gives you a real-time data stream. Kinesis Video is optimized for video input. So it's kind of got, put media, get media. It's backed by S3 for highly durable and secure storage. And what's nice is you can be fairly flexible about what type of retention policies you want on this data, which is important because as you start using that video stream to do, for example, machine learning analytics of it, you may want to go back in time as the machine learning may not be exactly in sync. It might be running a couple of seconds behind in that. So you can pull out of this the exact frame so you can do overlays, for example. Now, we've got Kinesis Video. So this is taking care of all of the streaming duties. Now, you can have thousands, millions of devices. You just set up a Kinesis stream for each of those devices. Now, we also have over here, we have recognition, which Ollie was just demoing as an image service. But recognition also has a video capability. Now, recognition video actually has two modes it can run in. One is it has a batch processing mode where you can take data straight out of S3, analyze it, and it'll do things like the facial mapping, it'll do event detection, object detection. Actually has a fair degree of sophistication in that. But what we're interested in here is the live streaming aspect. So to do live streaming, what I need to have is I've got my Kinesis video stream here. I'm actually going to create a Kinesis data stream over here. And so this is kind of my output. This is where I want detected faces to be put that are detected in recognition video when it's in streaming mode. So what I need to do is in the middle here, I need to have a processor. Now this processor is actually part of the recognition service. You just use the API to create it. There's no service, it's serverless, which we all love. It's taking the input from Kinesis Video. It's using recognition video to apply the machine learning models, and then it's outputting all of that metadata into Kinesis Streams. And then from Kinesis Streams, we have a client that's subscribed to the Kinesis Streams that's able to process that metadata. So let's have a look and see what it is. Now, as we mentioned, it is a little bit laggy because of how it's working and the traffic here. But if you look at this, hopefully it's going to come up. So it's going to detect the faces. And so you can see here, and you see the video's a little bit late, but it's actually 16 seconds behind at the moment. But it's detecting, this is the Kinesis feed that you're seeing here. It's detecting one face with 99% accuracy. And as I turned my face away, it can't recognize the face, so it went back to no faces found and as I face. But actually, Ollie, if you step in, what we should see as we both look at this camera in a couple of seconds is it's going to come up with two faces found as it works. There we go, two faces found. So you are, it's not detecting that you're a celebrity, but it is detecting that you're a face.
Admit it, you just didn't use the celebrity API here, didn't you?
I was just annoyed it didn't think I was a celebrity, to be honest. So this is actually doing a live stream. Now, one of the challenges with this is quite good, when you're thinking about a single device. But as you can see, it's quite bandwidth intensive and it's very latency sensitive. As we're here in Singapore right now filming this, and this is actually going all the way, some of it's going to Oregon, some of it's going to Ohio. There's some processing happening across the two regions, packaging that back together and then bringing it back to Singapore. Speed of light does matter at distance. This is where I think edge computing really starts to come in as a new technique that can be used as how do you push as much of this processing out to the edge where the data actually is and only send back what's relevant. It'd be good if we had a way to show that actually.
Absolutely. But before we get into that, Glenn, I got to mention, I saw him try to compile that C code yesterday. I think he was sitting on it for hours and hours, not properly writing your C code. Glenn, I'm a little bit disappointed. I thought you like that C code kind of age, you should throw that out of the box, no problem.
Yeah, look, it's been a while since I've had to play with autoconfig, to be honest, and memory allocation and free memory pointers. But
respect to all the C coders out there.
I'll tell you what, I've got a newfound love for the simplicity of Node.
And I absolutely agree with that. So sometimes it can be a little bit cumbersome to write some of these pieces of code to actually stream things in. So wouldn't there be a better way to actually do this? Now, we wanted to enable developers to better actually make use of computer vision at the edge location without actually the need to write your own code and models and get started relatively quickly. And so that's one of the reasons we actually launched the AWS dplans at our last re:Invent, which I'm actually holding up here. So AWS dplans is a little device that allows us to actually tap onto the camera and then run machine learning models at the edge, on the device. itself.
Pretty small device. Often you think with machine learning you need some pretty powerful equipment. What's inside?
Yeah, well, so it has obviously an Intel processor inside here, but it also got a GPU inside here. And that allows us to do some interesting machine learning models with computer vision and identify things like objects, or identify things like hot dog, not hot dog. You see that Silicon Valley episode?
Yeah. Everyone loves to see what's a hot dog or not.
So what I thought would be cool is let's try to see that live. So if I flip over here onto the camera, you will see that on my screen and also behind me here, we actually see what the Deep Lens is currently streaming. And you can see that if I show around here, this is the wonderful broadcast room with us around it that we're using here, and Glenn. And as you can see throughout that feed as it comes through, and I'm streaming this to my laptop from the Deep Lens device itself, it actually draws those boundary boxes around what it identifies and the different objects it identifies, so that we understand with a certain probability we can see things. So one of the things, here's my red little flitzer here. If I try to put some of these objects in front here, you will see that it starts identifying those objects, and with a certain probability. So now we identified that car, and you see 90% probability. There's your motorbike slowly coming through. We maybe have another little person here that we could put in front. And you see, we in a 2-day hackathon, you got to rely on some toys to actually make these things work. And there we go, person here. Now, interestingly, Glenn, what you see here is actually completely processed on this device locally. So the benefit here is I could go ahead and completely disconnect the Wi-Fi, and I would still be able to identify these objects here in a disconnected manner. And when I reconnect, I could transmit the information of what I've seen over a period of time back into my cloud environment for further processing.
That's great. And what Greengrass is providing as the kind of container or wrap around this is that ability we talked about. What if you had thousands of devices, for example, as Ollie's playing with the plush toys? What Greengrass allows is you can have a safe, secure environment where you can deploy these updates, deploy those models consistently. But what's interesting is, again, what if this device lost connectivity? If it lost its network connectivity, it doesn't stop processing because that model is running locally. It can keep running. It's going to queue up the information here around what objects it's detected, and when it reconnects, it's going to update the device shadow because this is actually connected to the AWS IoT platform. Now, Ollie, I know one of the interesting things here is that because it is connected to the IoT platform, makes it really easy to integrate with other smart devices.
That's absolutely right. Now, with that in mind, I figured before I do that, I want to show you the architecture of what we're trying to build here. And this time around, I was a little bit too lazy to draw it on the whiteboard. So I figured, how about I just show it on my screen here. Now, what you see here is actually the architecture that we would be running with this little scenario here. And as you mentioned, IoT, there's actually a Greengrass core that runs on that Deep Lens device here. And the reason we're doing that is for a variety of things. The first one is, if you look at that model, that machine learning model that's running on the device itself that draws those bounding boxes of the identifying if it's a car, motorbike, it actually runs in a Lambda function on that device. That Lambda function that obviously runs on Greengrass is identifying those objects here. Now, why do we do that? Because it allows us to deploy models out easily. So if we use something like Amazon SageMaker, I could go ahead and train a new model. Like I could take 1,000 pictures of you, Glenn, and train SageMaker. Right? Well, I could ask you for it, and we get a celebrity right there, right? Can put it in there, and then put it into the Lambda function and transmit it via Greengrass, right? Deploy it out to the device. So that makes that deployment and updating of the model really easy, right? Because we want to run the model on the device itself, but we want to keep updating.
One of the things that I really like about Greengrass, it abstracts the hardware platform because it is kind of a container-based technology. So you may use Deep Lens to develop and test these things out, but when you look to deploy 1,000 security cameras out in the field looking for these objects, that may be using a different hardware platform. But as a developer, you don't need to worry about that because Greengrass will hide some of that complexity behind the scenes, that undifferentiated heavy lifting. So Ollie, it can see what it sees there. If you go back to your video screen for a second. How about can we integrate it with Alexa, for example?
Of course. You know, it's always fun to do a few Alexa skills, and as you saw earlier on the architecture diagram, I built a little Alexa skill for it to actually tell me what it is seeing right now. So let's try that out. Alexa, ask Deep Lens what it sees.
I currently see a car and a motorbike and a person.
There we go. So basically the information here that we saw was stored in Greengrass, and specifically I stored it in a shadow on the device itself, but that shadow synchronized back to my cloud environment when it's online, and that allows me to build a skill to read out those object informations. Now, I see
I've
Glenn
removed the motorbikes. I want to see if this is another one of your, like your
little
recognition
can demos.
Little can demo. Alexa, ask Deep Lens, what does it see?
Sorry, I don't know that.
See, it doesn't understand
the Australian
I have
accent.
my voice profile on, my friend.
There we go.
Alexa, ask Deep Lens what it sees.
I currently see a car and a person.
Oh, so I didn't notice the motorbike has gone.
I can do the real life
Very
demos,
cool.
Glenn.
That is good. Well, it's good to see. So a really interesting use case showing localized modeling happening on the edge being processed in this device, which will actually be generally available actually quite soon, in a couple of months' time.
Absolutely. Now, with that in mind, one of the other things that I found quite interesting here is with Greengrass Core deployed on the local side, we could now think big. And obviously, this is a tool that allows developer to quickly get started with this kind of machine learning models, computer vision at the edge. But if we go into that industrial kind of scenario, we might deploy thousands of cameras. And this is where Greengrass then becomes really handy, because we can consolidate that information locally on our edge, identify at the edge, and only transmit back what we actually require. You really like to play with toys.
I do like to play with toys.
Don't
there
you?
we go. But one of the questions we had with this is great. It's using a model that can detect objects. But what if I want to get really specific and, for example, identify things like, what is the actual model of the car? And this is where using SageMaker to actually train models and experiment and then apply the model that's been trained and learnt back to the device can make a lot of sense.
Absolutely. And with SageMaker, we can train a model, we can do image transfer learning. But Glenn set me a challenge. He said, can you use SageMaker to tell me what color the car is? And I said, Glenn, yes, I can do that. I can take thousands of blue pictures, red pictures, green pictures, train a model, classify it. Or I could just change that Lambda function and say, when I detect the bounding bots, just look at the distribution of the pixels inside. If I see lots of blue, it's blue. Computer vision is not always the right answer to every problem.
And that's really important on the edge, because sometimes you can be quite constrained in the CPU, GPU. So any kind of trick you can do to reduce the computation left on the edge can have a big impact, whether it be performance or sometimes, a lot of the time in some of these devices, battery power actually really comes in. So less computational power you're using, the longer run times you have on batteries. So,
but, you had a point about it, right? Because I was thinking, the color, I can do my little cheating tricks here again, right? Don't I? But what if I want to actually detect a brand, right? What if I want to say this is a specific brand of this bicycle or motorbike or car? This is where transfer learning comes in. So if you look at Amazon SageMaker, it actually comes with inbuilt algorithms, inbuilt machine learning algorithms around classification, around clustering, around natural language understanding, topic modeling, but also image classification. And so what we can do there is we can do what is called a transfer learning on a convolutional neural network. So we can take that image classification model that we provide fully trained in Amazon SageMaker, and we can go ahead and say, if we look at that neural network, actually the biggest chunk of it is identifying the different features in a picture. And only the last layer, right, is basically where we identify, oh, this is now a car or a motorbike, etc. So what we can do is we can do a transfer learning where we just take that last chunk and retrain it with what we want to classify. So what I could do is just retrain that last layer using Amazon SageMaker with the different car brands that I want to identify, and then go ahead and push it out using Greengrass comfortably after being trained with Amazon SageMaker onto my deep lens.
So that gives you the end-to-end experience of what you need there, from training, learning to running of the model. So hopefully this gives you a good idea as to what's possible. Like I said, this was actually done in 2 days. It was a lot of fun. But it's kind of what's interesting is just, again, how fast this is moving. You think some of these technologies we're demoing just now were only released at reInvent in December, only a couple of months ago. I'm really looking forward to 2018 as we get through the year, just how much this is going to evolve again. The hardware, the software, the services, the ease of use, and making it more accessible to more people as they come out there. Where do you see it going, Ollie?
Well, I mean, look, I think for me, being able to set ourselves a little challenge here, sit down for 2 days and build a lot of different demos that include language processing, computer vision. I can talk to Alexa. We built this, and let's be frank, we're not the best software developer. We're a bit rusty.
I think I proved that already.
Right?
Yeah.
We do our proof of concepts, but once in a while, it's not like we're these hardcore developers. So I think one of the things that I'm really excited about is the ability to now tap onto all these either way pre-trained machine learning model or build your own machine learning models really quickly. Make a few API calls, click a few things in a console, plug something together and build a little POC around it. And we're only starting to scratch the surface what's really possible with machine learning. And so what I'm excited about is really to enable people to be able to use machine learning technologies without the need to understand always the complete underlying baseline and start building it from scratch. And that's what allows people to really innovate quickly without the need to actually build those foundations. If you want to, of course you can, but now you have the ability to move really, really fast in this space.
Awesome. So there's been a couple of questions coming through. So the first question was, is the sentiment analysis being done in the English language only, or can it support other language sets also? So at the moment, Comprehend can only understand English and Spanish. But there will be more languages coming as it evolves. So there.
I take the one here. The Sanal Belgi is asking, can we integrate face recognition with Alexa for business? Would this be a feature request? So what you saw right here when I asked Alexa actually to identify these objects, I wrote a little skill for it. So with the Alexa voice services, our general approach is allow any developer to build their own skills. If you watch the Alexa for Business specific session, you saw that we can also do private skills. So if you're looking, for example, into building your own model to identify who was in that meeting room, that could be a private skill in Alexa for Business that you deploy out. Having that in mind, we always happily listen to our customers. So if we see that as a really, really useful skill, maybe we integrate it by default. Or my suggestion to you would be publish your skill, because anyone can publish a skill, and then anyone who's using Alexa voice services can, if they want to, actually enable that skill.
And skills are easier. We're actually seeing code camps with kids learning how to create their own skills as well. Things like superhero databases and all types of fun things. An interesting question here has been, though machine learning's been around for a couple of decades, it's still a baby. What are Amazon's future plans to get this to a wider mass? That's a really good question. And this kind of evolves around the philosophy we have around machine learning, in that we actually want to cater for all users of it, whether it be those power users that are going to be very, very comfortable building in MXNet and TensorFlow and using EC2 directly with GPUs, even field programmable gate arrays, for example. That's at one end of the spectrum. Then at the other end of the spectrum, you have the services themselves, where you don't even need to understand about machine learning. I just want to apply machine learning to a use case through things like recognition or Lex and Poly for voice. And then in the middle, you have services like SageMaker, which you tapped on, which is a really easy tool to get used to for data scientists, for example, who may not want to understand the infrastructure running behind it, where they can define their training models, experiment with it, see what results they get, and keep running that, and then push those models back out to other learning platforms. So that kind of gives you a bit of idea of where we're seeing, where we see the developments happening. It's actually across all three areas, but the general trend you're going to continue to see is just making this simpler and simpler for people to use, and try and remove as much of this complexity as we can, so it is easier for more people to use. So I think with that, we're out of time, Ollie. I just want to close why this has been happening. The good thing about live demos, I've been watching the Twitter stream still here on my screen, and it sounds like the cross-country women's event was absolutely smashed with a very close finish. It's going absolutely crazy with people just shouting out how good that was.
Team USA, we can learn lessons.
Yeah, so it's great to see. So with that, Ollie, any closing remarks?
Well, I'm really excited about things, and keeping this in mind, this is a true demonstration of scale. So one of the things I'm really psyched about, apart from what I was saying, is things to scale. So look at what we have to offer, look at the different machine learning models, APIs that are available. These services are designed for high scale, and it allows us to really build some really cool applications very cost effectively. So with that in mind, go out there and build and train machine learning models.
Awesome. Look, on behalf of Amazon Web Services, thank you very much for joining us for this special edition of Innovate. It's been an absolute pleasure to spend time with you. Hopefully you've learned something. I know Ollie and I have had a lot of fun putting this together. With that, there's never been a better time to build, so go build. Thank you very much.
Thank you.